All right, now we're on chapter 2, all about motherboards. Motherboard types and features. Motherboard, most complicated computer component. One of the first items to consider when building a computer. Considering the following when purchasing a motherboard. The form factor, right? What kind of case you're going to get. How's it going to fit. Your processor, socket, and chipset. Make sure they're compatible with your motherboard. Expansion slots. How many do you need? How many do you think you're going to need? And other components, slots, and ports. Here's a figure of a Asus Prime Z37P gaming motherboard using the ATX form factor, an LG A1151 8th generation process socket. It's an Intel. Motherboard form factors determine the motherboard size and features that make it compatible with power supplies and cases. The most popular are ATX, Micro ATX, and Mini ITX. Mini ITX is smaller than Macro ITX, is also known as MITX. The following slides shows examples of form factors and comparisons of size, hold positions, and of several small form factors. This is the Intel desktop motherboard DH676D, which uses an MATX form factor and has the processor, cooler, and the memory modules installed. This is a Mini ITX motherboard. I see it's a lot smaller, less expansion cards, right? As compared to the other one. Right, this one has two here, one here, and one here. Here's the form factors, motherboard sizes, and the descriptions. Size and host positions for the ATX, Micro ATX, and Mini ATX motherboard. This is as far as the case is concerned, right? How you're gonna, depending what kind of case you're gonna get. A chipset is a set of chips on the motherboard that works closely with the processors to control the memory, buses on the motherboard, and some peripherals. Must be compatible with the processor it serves. A socket is rectangular with pins or pads to connect the processor to the motherboard. Two major chipsets and processor manufacturer, Intel and AMD. Intel chipsets, Coffee Lake, Kaby Lake, Skylake, Broadwell, and Haswell. Since the release of second generation of Intel family of processors, each generation a processor fits in by the 4 digits in the model number. Example, the Core i5-6200U processor is a 6th generation processor. The 8th generation LGA 1151 socket with the cover removed and the load plate lifted is ready to receive the processor. So here, remember we talked about the zero insertion force? This is it right. Once it locks in place, once you plop in the CPU, you just put it in place and it forces it in. Like, it doesn't force it in, but it puts it in place and locks it in place. Sockets for the Intel processors, current Intel sockets for desktop computers are LGA 1151, 1150, and 1155. Intel sockets used in servers and high-performing workstations, 2066, 2011, and 1366. The 7th and 6th generation LGA 1150 open socket and the bottom of the Intel processor. This is the ZIF right here. The LG 1366 socket with the socket cover removed and the load plate lifted, ready to receive a processor. ZIF, zero insertion force, are used to lift the processor up and out of the socket using lever. AMD chipsets and sockets, current AMD chipset and socket categories for personal computers. TR4, Threadripper 4 socket uses AMD X399 chipset. AM4 chipset family, a AM4 socket is used with AMD Ryzen and Atheon processors. AM3 Plus and AM3 are PGA sockets used with AMD Power Driver and Bulldozer processors. FM2 Plus is an older PGA socket used with AMD Athlon, Steamroller, and Excalibur processors and the A series chips. Match a processor to the socket and the motherboard. You must pay close attention to the actual model number of the processor to know which socket it requires and which motherboard can support it. This is when you're building your own PC. To match a motherboard to a processor to a motherboard and socket, look up the motherboard's manufacturer's website or user guide for a list of processors the motherboard supports. You can also search the Intel or AMD website for the exact processor to make sure the sockets it uses is the same as the socket on the motherboard. Fine lines can be found on both the top and the bottom of the motherboard, called traces. Traces are circuits or paths that enable data, instructions, timing signals, and power to move from component to component on the board. Bus, system of pathways used for communication, and the protocol method used for transmission. A protocol is a set of rules and standards that any two entity use for communication. Here's the trace. On the bottom of the motherboard, you can see bus lines terminating at the processor socket. PCI Express, PCIe currently comes in 4 different slots. PCI Express X1, 4, 8, and 16. The number X refers to the number of lanes available for the data. For example, PCIe 4 contains 4 lanes. PCIe X16 slot is used by the graphic cards that require large throughput to provide extra wattage required for cards that require large throughput. The card may have 1, 2, or 3 connectors to connect the card to the extra power. But if you have a card that's an X8, you can't put it in an X4 slot, and it will run at the X4 speed. So just know that. 3 times of expansions. Here it is, the X1, 16, and conventional PCI slots. Here what it will look like in your documentation. Here's your SATA power connector, auxiliary power connectors for the PCIe. Here's auxiliary power connectors to support the PCIe. In case you need it, not all of them may need it. Video cards are most likely. Conventional PCI slots and buses are slower than those of PCIe. Slots are slightly taller than PCIe slots, transmit 32-bit data bits in parallel and operates about 500 megabits per second. Used for all types of add-on cards. Riser card used to extend the slots. A low profile slimline case may not give you enough room to install an expansion card standing up in a slot. A riser card installed in the slot provides another slot at an angle. Riser cards comes in all types of PCI and PCIe. So if you need it longer and it doesn't fit, you put this in here and then you can put it at an angle. I haven't seen a riser card in years. Ongoing ports, integral components. Ports coming directly off the motherboard may include USB, PS2, keyboard, video, sound network, etc. I/O shield, plate installed in computer cases, providing the holes for the I/O ports. Internal connectors, USB, M.2, SATA, IDE connectors. Here it is, back of the computer. Here's the I/O shield that fits the motherboard ports. SATA, Serial Advanced Technology Attachment for Serial ATA, an interface standard used mostly by storage devices. Current version of SATA, SATA Express, SATA 3 and SATA 2, M.2, formerly known as Next Generation Form Factor, uses the PCIe, USB, or SATA interface to connect a mini add-on card, commonly used by wireless cards and solid-state drives. That's an M.2 slot there. Here's an M.2 slot key with a notch to hold an M2 card with a B key or M key edge connector. That way you can line up the slots correctly. IDE, Integrated Drive Electronic Standard, used to interface storage devices with the motherboard. An IDE connector has 40 pins. USB header is used to connect the cable from a motherboard to a USB ports on the front of the computer case. This is an IDE connector right here. One connect goes here, and the other end usually goes to hard drive or DVD or CD. This is the cable that connects to it. Two USB headers are used to connect the motherboard to the USB ports on the front of the computer. There they are right there. Firmware to the motherboard is used to enable or disable a connector port component, control the frequency and other features of the CPU, manage security features, control what happens when the computer first boots, monitor and log various activities on the motherboard. This is when you're using a BIOS UEFI setup. Motherboard made after 2012 used BIOS UEFI firmware. Prior to that, they just used BIOS. UEFI, Unified Extensible Firmware Interface, improves on BIOS but includes BIOS for backward compatibility with older devices. Facts about UEFI. Microsoft requires UEFI in order for systems to be certified for Windows 10 8. UEFI is required for hard drives larger than 2 terabytes. UEFI offers secure boot, which prevents a system from booting up with drivers or OD that is not digitally signed and trusted by the motherboard or computer manufacturer. From backward compatibility, UEFI can boot from an MBR hard drive and provide a BIOS boot through compatibility support module feature. Access to BIOS UEFI setup program is by pressing a key or combination of keys during the boot process. For most motherboards, it's F12 or F2 or the delete key during boot up. If you don't know which one it is, see your documentation of your motherboard and watch the screen near the beginning of the boot. Setup screen appears with menus and help features. Here's the BIOS UEFI setup screen. Shows the list of drivers installed on the system. Information about the system is required to access BIOS UEFI. This is more UEFI. This is more BIOS right here. What are the main differences? I don't know if it tells you here. But here you can use the mouse. Here you cannot use the mouse. You got to use the keyboard. Here, sometimes you can update your firmware here. Here you can't. Not directly from there anyway. In the BIOS UEFI setup boot menu, you can set the order in which systems tries to boot for certain devices. Call the boot priority order or boot sequence. Which one you want to go with? CD first, that loads first. Hard drive, USB, floppy if it has any. Boot priority order. Examples where you might need to change the boot priority order. Some distributions of Linux can be installed on a USB flash drive. So you can boot from the OS from this drive when you put the USB device first. When installing an OS on a hard drive, you may want BIOS UEFI to boot first from a DVD to install from a setup DVD. If you're installing an OS from a server, you can put the PCI LAN EFI network option at the top and enable PXE boot to LAN. That way you can, if you want to boot up from the server, right? If you're installing OS from a server, you can set it up so that it can install. You turn on your computer and it gets the files from the server. Boot from the Windows setup DVD to troubleshoot a computer that would not start. Manage Secure Boot. Secure Boot was invented to help prevent malware from launching before the OS and anti-malware software are launched. Secure Boot works only when the boot mode is UEFI and the OS supports it, supported by Windows 10 and 8 and several distributions of Linux. Secure Boot holds digital signatures, encryption keys, and drivers and data rates stored in flash memory on the motherboard or the hard drive. When enabled, it checks each driver, the OS, the applications before the UEFI launches these programs to verify it is signed and identified in the Secure Boot database. Manage Secure Boot on the security screen of BIOS UEFI setup. Where is it? Security. Oh, that's it. Secure Boot is enabled right here. Manage CSM and UEFI boot. The boot screen allows you to select UEFI mode of compatibility support module mode. UEFI mode is required. For secure boot to be enabled, use CSM for backward compatibility with older BIOS devices and drivers and MBR hard drives. That's master boot record, MBR, master boot record. Use CSM to boot a legacy BIOS system or disable it to implement the UEFI secure boot. You can enable or disable some onboard devices using BIOS UEFI setup. For example, network ports, USB ports, and video ports. What you can configure on your system depends on the board devices the motherboard offers. Overclocking, running a processor, memory, motherboard, or video card at a higher speed that the manufacturers recommend. Some motherboards and processors allow overclocking, but it's not recommended, right? Because it will decrease the lifespan of your PC. And it voids the manufacturer's warranty. You know, usually gamers like to do this. It'll get the PC really, really, really hot also. You can enable and disable hard onboard devices like video, the LAN, the HDMI port, etc. Other security features besides secure boot: power on password. As soon as you turn it on, it asks you for a password. Low jack. If you ever seen low jack for cars, in case they steal your computer, you can track it. It's like a GPS. Drive password protection. Again, as soon as it comes up, it gives you a password. TPM chip and drive encryption kind of work hands in hands with BitLocker, right? Where if somebody takes your hard drive, the hard drive and the motherboard are in sync. And if somebody takes your hard drive and puts it on another computer, unless they have the keys to de-encrypt it, the hard drive is useless. It's encrypted. So that's BitLocker, and I think we'll learn more about that. Power on passwords. Power on passwords are assigned to BIOS UEFI setup and prevent unauthorized access to the computer or BIOS setup utility. Depending on the motherboard, it may be possible to set up a supervisor and user password. How to set passwords varies depending on motherboard and BIOS. And this was the feature that was used way before Windows. You know, when it gives you an option to log in. This is what people used to use to log into their computer, power on password. So you can set supervisor and user password and BIOS UEFI to set up to help lock down the computer. That means nobody can go in the BIOS. Laptops for low jack technology, low jack and CompuTrace agent technology embedded in the firmware of many laptops to prevent a system against theft must subscribe to the service. The service can be used to locate a laptop whenever it connects to the internet. Once located, you can give commands through the internet to lock the laptop or delete all data on it. Drive password protection. Some motherboards allow you to set a password in order to access the hard drive. Does not encrypt all the data on the drive, but encrypts only a few organizational sectors. A TPM and hard drive encryption. Many motherboards contain a chip called Trusted Platform Module chip. The BitLocker encryption tool in Windows 10, 8, and 7 works with this chip. An encryption key or startup key is kept on the chip. Assure that a hard drive cannot be used in another computer once it's on. Right? You got to turn BitLocker on. Can be used with other encryption software that may be installed on the hard drive other than BitLocker. If the motherboard fails and is replaced, you need a backup copy of the startup key to access data on the hard drive. BIOS support for virtualization. Virtualization is when one physical computer uses software to create multiple virtual machines. A virtual machine simulates the hardware of a physical computer. Each VM works like a physical computer and is assigned virtual device such as a virtual motherboard and virtual hard drive. Virtualization must be enabled in BIOS UEFI setup. On the older laptops, it's not by default, but on the newer ones it is. And you can really tell if you don't have virtualization installed. If you try to install Oracle VirtualBox and you try to create a VirtualBox and it's only giving you 32 bits. Options only to create like a Windows 10 version of 32-bit. Then you know your virtualization is not turned on. When you finish with the BIOS UEFI setup, an exit screen gives you various options, such as saving your changes, exiting, discharging your changes, and exiting. Some offer the option to load optional defaults. This option can sometimes solve a problem when a user has made several inappropriate changes to BIOS UEFI settings, or you are attempting to recover from an error created when updating the firmware. Here's the BIOS UEFI utility exit screen. When a motherboard is causing problems, or you want to use a new OS or hardware device, you may need to update the motherboard drivers or update the BIOS UEFI firmware. Device drivers are small programs that allow software to interact with certain hardware. The CD or DVD that comes with the motherboard contains a user guide and drivers for its onboard components. After installing a motherboard, you can install the drivers from CD or DVD and later update them by downloading updates on the motherboard's manufacturer's website. Sometimes updates are included in updates to Windows. Be sure to get the correct drivers for the OS edition and type. For example, if you're using Windows 10 64, get those drivers for the Windows 10 64. Don't get the 32-bit drivers you are using with the board. Download drivers, utilities, BIOS, UEFI updates and documentations, and other help software from the motherboard's manufacturer's website. The process of upgrading or refreshing the program and data stored on the firmware chip is called firmware or flashing the BIOS, UEFI, or flashing BIOS. Reason to flash: the system hangs at odd times or during boot. Some motherboard functions have stopped working or are causing problems. You get errors when you try to install new OS or hardware devices. You want to incorporate some new features or a new component on the board. To flash the motherboard UEFI, always follow the directions found in your user guide for your motherboard. Motherboard can use one or more of these methods. Download an update from within the BIOS UEFI setup. Update from a USB flash drive using BIOS UEFI setup. Run an express BIOS or UEFI update. Cautions to be aware of when updating. Don't update firmware without a good reason. Back up first. Select the correct update file. And don't interrupt the update, i.e., do not shut it off. Using jumpers to clear BIOS UEFI settings. A jumper is two small posts or metal pins that stick up from the motherboard that is used to hold configuration information. Open jumper has no cover and a closed jumper has a cover on the two pins. Jumpers can be used to clear a forgotten supervisor or power on password. If flashing the BIOS UEFI fails, a jumper can be set to undo the update. Right there. You got to look for it. A 6-pin jumper group on a circuit board. A has no jumpers on the set and has no jumpers set to on. B has a cover parked on one pin. Or C is configured with one jumper setting turned on. So again, you need the manufacturer's book. Jumper, that's the normal default. The current BIOS configuration is used for booting. Configure, after post, the BIOS displays the menu and BIOS setup that can be used to clear the user and supervisor power on password. And recovery is used to recover from a failed BIOS update. Details can be found, again, on the motherboard manual. CMOS is a method of manufacturing microchips. CMOS RAM is a small amount of memory stored on the motherboard that retains data even when the computer is turned on, like the time and date, for example. It is charged by a nearby lithium coin cell battery. To replace a CMOS battery, choose the correct replacement battery. Must be an exact match to the original or the manufacturer's recommendation. Power down the system, unplug it, press the power to drain the power. Press the power button to drain the power, remove the case cover. Use ESD strap, remove the old battery using a flathead screwdriver, and you pop the new battery in place. Installing and replacing a motherboard. A motherboard is considered a field replaceable unit. That means when you're driving to a location, make sure you have one with you. A technician needs to know how to select an appropriate motherboard, install or replace one in a desktop or laptop. 3 approaches to selecting a motherboard. Select the board that provides the most room for expansion. so you can upgrade and exchange components and add devices easily. Select the board that best suits the needs of the computer's current configuration. Select a motherboard that meets your present needs with moderate room for expansion. Ask the following question when selecting a motherboard. How is the motherboard to be used? What form factor does the motherboard use? What brand, Intel or AMD, and model processor does the board support? Which chipset does it use? Which processor does it support? Which type and speed of memory does the board support? Continue. What are the embedded expansion slots, internal, external connectors, and device on the board? Does the board fit the case you plan to use? I think that's most important. What are the price and the warranty on the board? Does the board get good reviews? Right, you want to do industry reviews and people who bought it reviews. How extensive and user-friendly is the documentation? And how helpful is the manufacturer's website? What warranty and how much support does the manufacturer supply for the board? General process for replacing a motherboard. Verify right motherboard is selected. Get familiar with documentations, features, and settings. Remove components to reach old motherboard. Install the IO shield. Install the motherboard. Install the processor and processor cooler. Install the RAM. Attach the cabling, case switches, power supply, drives, etc. Install video on the motherboard. Plug the computer into power source. Attach the monitor, keyboard, and mouse. Boot the system. Enter UEFI BIOS. Observe the post with no errors. Verify that Windows starts with no errors. Install the motherboard drivers. Install other expansion cards and drivers. Verify that the system is operating properly and make the final BIOS and UEFI and OS adjustments. For example, setting power on password, if that's what you choose to do. For a laptop, you may need to disassemble the entire laptop. Consider alternatives before proceeding. General procedure for replacing the motherboard on a laptop. Update Windows and device driver and make sure Windows is working properly. Disconnect the AC adapter and press F and a function plus S plus V to set the battery in ship mode. Remove the hard drive slot compartment cover and the hard drive. Next, remove the slot compartment cover that gives access to the memory and the mini PCIe card, and then remove those components. Remove the keyboard bezel. Remove the 13 screws. Detach the touchpad and keyboard ribbon cables from the two FPC flexible printed circuits connectors. To detach the system board, remove the 5 screws holding it in place, and then remove the ribbon cable connecting the speakers, hard drive, optical drive, USB ports, battery, camera, and LCD panel. Follow the directions in reverse order to reassemble the system. It's not easy, guys. It's not an easy thing to do. Right? Detach system board from jacks on the left side. It's very, very delicate, as you can see. So I've never done replace a motherboard on a laptop, and I probably don't want to either. All right, and here's the summary of the chapter. You can read that on your own, and we are done with chapter 2.